and get the y's and x's separate. Any math that you can do earlier than calculus. You can take like sections of a cone and do conic sections. You can take matrices, you know that stuff. Circles, you can do like lines and parabolas and all that kind of stuff. Well, if you take those and how they change over time, not just how they exist in one, those are like little cross sections, like, you know, but how that happens over time, you get to derivatives and integrals and calculus.
It's easy to understand. So when you're doing an optimization problem, for instance, you're looking at a graph and you're graphing the area based on certain parameters, the length and width of the box as they change, what's actually happening to the area. Applicable to all numbers.
So we're going to talk about calculus, just in terms of everyday life. You know a little bit, like you know basics of like what it is.
Sure, yeah.
Like math change.
So all the elements contained in the real number set, which is important because one of the major theorems is that there's continuity. Like you can go to an infinitely small number. That's important.
It's just the math of change, right? You're everything that you can do in an earlier math, you can take that and find its change over time. Alright, as the night progresses, we're going on to my brother Landrum. He's actually a math major at LSU. Oh. Yeah, I'll cut it out. It doesn't. You know, I can find the volume of a Cinnabon delight as it's moving around an axis. Integrals and derivatives are opposites. How you feel about this Calculus the Musical, I Believe in a Power Rule?
It's interesting.
Yeah. So what do you like about math?
I like that it's like once you figure out a formula and you like memorize the steps on how to do it, it's the same thing over and over again. And I like that I don't have to think too hard about it. If I have like a calculator, I can just put it in and it's done.
Yeah.
Everything is related, so it's important to understand all of this. You know, we always want to get to the core fundamental of what is actually going on around us. That's the ultimate goal.
Calculus.
Go integrals and derivatives.
Yay.
Love you, Sal.
But anyways.
So, alright, so this is Molly.
Yes.
And what math are you in?
Algebra 2.
Okay. What do you like about math?
I like patterns.
I'm gonna go around and talk to everyone here about calculus. Maybe I'll talk about related rates. So related rates are these problems where you're given like a real life scenario. Like a sailboat is sailing against the wind in a specific time. You're given variables in terms of time and change.
I remember when you told me about this.
And you take derivatives of like equations for like triangles if they're moving in a triangle, or like circles if they're gonna move into a sphere, or things like that. And you plug in like it's like mostly figuring out what to plug into what's time, what's a fixed, like a ladder is a fixed distance, but a changing distance is like someone walking away kind of thing.
No.
Okay, so Lexi is learning trigonometric functions right now. She's learning the identities. As you can agree, stuff you must recall, you really have to know those things. Like, you have to know.
But there's only certain ones.
Like, sine squared plus cosine squared is 1. Secant
Like
squared
1/5.
equals tangent squared plus 1. Cosecant squared equals cotangent squared plus 1. Because the cosecant cotangent pair and secant tangent pair follows into derivatives. So this is Andrew Lawrence. Andrew, your differential equations, which is like you're given derivatives in terms of y's and x's on two sides of an equation, and you're trying to like cross them and work them out by integration. Alright. Okay, so volumes by slicing. Imagine you have a graph on a piece of paper right here. You have an x and y axis, and then like some sort of curvy line.
Yeah.
So you see that shape right there. Now imagine each cross section as a line, up and down. So like stripes, vertical stripes. Each of those is the bottom side of a square that comes out of the paper, right?
Okay.
But since they're like, they change in size, the heights change in size because all the like squares, like the base and the side, all four sides. So if you have like a shape that's like this.
Thank you.
These squares are going to be shorter than these squares, which are getting wider in bases, so they're taller, right? So these are shorter, so they're shorter. Do you know about derivatives from advanced math a little bit?
Yeah.
Do you know about integrals?
No.
Okay, so I have to talk about integrals. So, at some point. So, derivatives go one way. Integrals go the exact opposite. In terms of time. So, like, you know how a derivative of like
Once
x
you get like 1 month, that's when it's like
would be 3x squared?
like, wow, that's a really
Well,
long
if you're
time.
given like
When you're
3x
at
squared,
10
you
months,
know it's
you're like,
integrals
yeah.
x cubed. So you get things like you go up 1 and divide instead of go down 1 and multiply. So if you're given x cubed, its integral is x to the 4th over 4. And that, you can see how that 4 would multiply to
Right.
1 over
Yeah.
4. So basic integrals. Like, that's how you would be good at it.
Thank you.
With that, what was your favorite part of the math? Like, what are your favorite topics?
So I really like geometry more than algebra 1 or 2. I sort of felt, and I know that goes with the theory. Yeah, pretty much.
Yeah, she teaches algebra to Yes, she knows the math things, but only sometimes. Don't ask her for help on math homework. She will not know what you're learning.
Oh my god, can we FaceTime Abby?
Can I taste this? Can I taste this?
The other one you just did to your hair, but it's bad. Yeah, there you go.
Red Bull.
I liked it. It was like, yeah.
Anyway, good night.